My name is Mahesh and I am recording this for my project demo of PDF AI RAG project. So before starting, I would like to explain about what it is. So this is a PDF question answering tool that implements a full RAG pipeline end to end. So when someone will upload a PDF, I parse it, split into the chunks, and run each chunk through Gemini embedding model to get vector representations. Then I store them in FAISS index, Facebook AI similarity search index. So when user will ask a question, I will embed the question the same way and retrieve the most relevant chunks from the vector database, and then build a prompt combining those retrieved chunks and the user message, and it will then pass to the Gemini model to generate the answer from that. There are few problems I also faced while testing it, like when I uploaded a large PDF size, so it hit the rate limit of the embedding model. So yeah, that is one problem because I am using the Gemini's free tier. So this was the complete flow. So now let's go to the VS Code. So yeah, so these are the requirements. I have already installed all these requirements. Then I have created a config. Then I have added. Then I have created a .env file where I have kept the API Google Gemini API key, and after that I have created a config file, and the config file also I have loaded the same way. So in the config file I am getting the Google API key. Then I have declared some variables like which models I am going to use. So for embedding I am using the embedding model 001. So I can also use Gemini model embedding for embedding model 2, which is the latest model. But for now I am using 001 for not hitting the rate limit. So and LLM modem I am using Gemini 2.5 flashlight, and the chunk size I have kept 1000, and the chunk overlap I have kept it as 200, and the vectors I am going to store in vector store FAISS index. So the next is the PDF loader, because the user will upload the PDF first. So this file is taking that PDF. So for it I have used PyPDF. It reads all the pages and written the Langchain document. Then the next file is the chunking.py. It splits the large PDF, creates chunks, and maintain overlap. So why we create chunks? Because suppose we have a file of 200 pages, 100 pages, so it can have around 40,000, 50,000 of words, and then if we will break them into the tokens, then it will be even more number of tokens. So in RAG we used to create chunks of number of tokens, like I have created 1000, I have set that to the 1000, and chunk overlap to the 200 limit. So those 50,000 words will get those 50,000 words will get converted into the chunks of the 1000. So there will be get created 50 chunks of the 1000. So I am talking about so this is I'm saying for the example, and why we keep overlap is to maintain the flow. So whenever we are going to retrieve the chunk, 3, 4, 5 number of chunks, so without losing the context between each chunk, we keep a chunk overlap. So starting of the previous chunk and ending of the next chunk, it will already got added to every chunk. So this is the chunking file. So after that I have embeddings. So for this I have already told. So for this I am using Gemini embedding model 001. Now the next is vector store.py. In the vector store I am FAISS and the vector DB path from the config file. And so in this file what is basically happening is building the FAISS index, and then saving that index and loading that index. So all those embedding will get converted and get stored in the DB path. So then there is retriever.py. So what retriever will do, like I told you that we have created chunks. So when user will type message, so it will go to the database and will find the top k is the number of chunks we are fetching. So it will find the top 3 chunks out of the vector database which are more similar to the user question. So it accepts the question, perform similarity search on that, and then returns k number of chunks. So in this case we have 3. The next is llm.py file. So we are loading the Gemini. We are loading and initializing the Gemini model, and we have configured the temperature here. We can also configure it in the config file, but configure the temperature also to 0.3, as this is going to be a so as user is uploading a PDF and we want the response strict to the PDF only. So we have kept the temperature low, because in this we want it to be more deterministic, not creative to add its own thoughts. So we want the LLM to respond to whatever thing present in the PDF only, and we have kept it 3. So little. Then we have chat history. So in this we have initialized a Streamlit session state, which store user and AI messages, and build conversation history. Okay. So now the next is our main UI interface part. So here it is. So we have imported Streamlit and all the previous files and methods. Now we have initialized the chat from the memory. So it is again the title, and then it will upload a PDF. The user will upload a PDF, so the PDF will get stored in the PDF's path. Then it will get split into the chunks, and those chunks will get passed to the embeddings, and those embeddings will get now stored into the vector store. Now when the user will ask a question, then it will go to the same embedding and will retrieve the top 3 chunks similar to the question, and then all these will get, then it will get passed to the Langchain. Langchain will then pass it to the LLM model with the history, if there is any previous history also, and then it will provide the response to the user, and the user message and the AI message will also get stored into the memory. So yeah, this is all about this PDF rag. So I have deployed it on the Streamlit cloud as well. So here I have already and I have downloaded already a service level agreement PDF. So I am selecting it. I have kept the size of the PDF relatively small, so the rate limit will not hit. So now I can chat with this PDF. So I am going to ask it what is this PDF all about. And so it gave me the answer. This PDF is a service level agreement between National Internet Exchange of India and a service provider, and some more details it has provided me. Now if I will ask, can you tell me more about this hosting, because there it is mentioned that it include hosting and managed service. So now I have asked it another question. Let's see if it. So based on the previous response, it also maintained that, and it so whatever things are covered in this SLA are displayed here, and it is quite accurate. So now if we want to test, like what happens if we ask some question which is not present in this PDF. So let's say I will ask who is Elon Musk. So let's see if it will answer or not. So it clearly says that I'm sorry, but I cannot answer your question. The provided tag doesn't contain any information about Elon Musk. So our tag is only focusing on the content provided in the PDF only, and based on that it is giving us the response. So yeah, this is all about this demo. Thank you.